Hi Year 6, I hope you've all had a lovely half term. This is Tuesday's maths lesson, so our first maths lesson back after the half term. And today we are going to be looking at line graphs. As usual though, we've got our 6 arithmetic questions and our 2 stretch questions before we go into the main part of our lesson. So if you pause the video now and have a go at the questions, and then we'll go through the answers. Okay then, hopefully you've had a go at the questions already. Question 1 then, again, is a BODMAS question. So in this question we have got a multiplication and we've got a divide. We've got to use BODMAS to tell us which operation to do first. And as the D comes before the M in BODMAS, we need to do the divide first. So first of all, we're going to do 6 divided by 2. 6 divided by 2 is 3. So then we're left with 4 times 3. 4 times 3 is 12. Question 2, we have got a fraction times by a whole number. When we times by a fraction by a whole number, remember, I like to remember it T for times, T for top number. It's the numerator that will change, the denominator will not change. So we're going to do 2 times 5 on the top, so our numerator becomes 10, and our denominator, remember that doesn't change, that will still be 4. Question 3, they love a question like this in an arithmetic paper in sets. We've got 8,235 equals 8,000, add something, add 35. And basically it's a place value question. It's looking at, can you spot that the missing number here is that 2 in the hundreds column, so the missing number is 200. Question 4, we've got -5 add 6. Remember, you might need to draw yourself out a little number line for this. It's absolutely fine if you do. We're starting on -5 and we want to add 6 to it. Well, if we add 5 to -5, that takes us to 0. But I want to add 6, so I need to add 1 more. So 0 add 1 takes me to 1. So my answer is 1 for this question. Question 5, 180 divided by 6. You could have drawn out a little bus stop for this, but the idea of this question is that you use what you know to help you solve it. And if you know that 18 divided by 6 is 3, then we can do 180 divided by 6, because 180 is 10 times bigger, that's why it's got a 0 on the end. 18 divided by 6 is 3, but we want an answer that's 10 times bigger, so we put a 0 on the end. 30 was our answer. Question 6, again, similarly to question 5, you could have written out a long multiplication to solve this, but an easier way would be to use what you know. So I would do 4 times 5, which I know is 20, and then I'm going to look at the fact that this is 10 times bigger than 5, so I need another 0, but also 40 is 10 times bigger than 4, so I need another 0. So my answer then is 2,000. Stretch, if you did that today, question 1, where the answer was 651,900. And question 2, if you did that one today, the answer was 47. Okay, over into our daily times table practice then. You know the drill. Give yourself 1 minute to have a go at the times tables on the screen, and then we will continue with our lesson. Okay, over into the main part of our lesson then, and as I said at the beginning of the video, what we're going to be looking at today is line graphs and interpreting information that is presented in line graphs. So I've got a couple of examples. I've only got a couple of examples though, because the main thing with line graphs is you having a go at doing them yourself. So we'll have a look at a couple of questions and then you will have a go at your questions on maths.co.uk. So here we've got this graph shows the temperature in degrees Celsius from 2 AM to 3 PM on a cold day. Okay, keys to success when we're doing this. Look at the information carefully. So I can see I've got the time of day on the bottom and I've got the temperature in degrees Celsius up the side of the graph. Okay, first question says, how many degrees warmer was it at 3 p.m. than at 3 a.m.? Right, read the question carefully. What is the question asking you? Well, this question is asking me how many degrees warmer it is. It's not saying what is the temperature at 3 p.m. It's not saying what's the temperature at 3 a.m. It's saying how many degrees warmer. So it's asking essentially what the difference is between those times. So first of all, I need to find 3 p.m. on my graph. So remember, time of day is along the bottom. So 3 p.m. find that, and I read up and I read across. So I find where 3 p.m. touches my line and I read across, and I can see that the temperature there at 3 p.m. is 2 degrees. So I'm going to make a little note of that. At 3 a.m., find 3 a.m. I go up to where it touches my line and I read across, and at 3 a.m. it was -5. So what I need to know to answer this question is, what is the difference between +2 and -5? Thinking back to what we did in our arithmetic questions at the beginning, I might need to draw myself out a little number line for that. That's absolutely fine. If I've got 2 there, put my 0 there. Right, first of all, I've got to take away 2 to get to 0. And then to get to -5, I've got to take away another 5. So all together, I've taken away 7. So the difference in temperature then is 7 degrees. The next part of the question, at 6 p.m. the temperature was 4 degrees lower than at 3 p.m. What is the temperature at 6 p.m.? So looking at my graph, 6 p.m. Okay, if I look up, I can see that my line, my temperature line, doesn't actually reach 6 p.m. But it does tell me that the temperature at 6 p.m. is 4 degrees lower than 3 p.m. So let's look at what the temperature was at 3 p.m. Right, so I find where that temperature touches that 3 p.m. line, and it's 2 degrees at 3 p.m. Okay, I can see that, I can draw a line across, it's 2 degrees. Now at 6 p.m. it's 4 degrees less than that. So I've got my 2 degrees and I'm going to count down 4. 1, 2, 3, 4, which takes me to -2. So at 6 p.m. the temperature must have been -2. Okay, so with line graphs it's just really important to look at the information you're given and read the question carefully. Okay, right, we've got another example here then. This graph shows, the height of a balloon at different times. Okay, so we've got height in meters down the side and time in seconds along the bottom. From the graph, find the height of the balloon at 50 seconds. So first of all, my time is along the bottom, I find 50 and I read upwards. Okay, now if I draw a line across from there, I can see my height in meters comes out here. Now I need to know what this line here is, halfway between 40 and 50. So what number comes halfway between 40 and 50? Hopefully you know that's 45. So that line there is 45. And my height is a little bit more than 45. So it's more than 45, but it's not as high as 50. So a sensible estimate here, and remember it's just an estimate, I can't know exactly from this graph, is 47 meters. Okay, so here is a test of, can you understand the scale and can you estimate? Okay, we've got to go a little bit higher than 45, a little bit higher than 45, we might say 46, 47 meters. Okay, the next question, use the graph to find how long it took the balloon to rise from 30 meters to 60 meters. Okay, so this time I need to read along the side, and I'm just going to rub my workings out from the previous question out, because otherwise it's going to get a bit confusing. Okay, so we're using the graph to find how long it took the balloon to rise from 30 metres to 60 metres. So 30 metres, if I read across, I go all the way across, and I read down, I can see it was at 25 seconds that it was at 30 metres. And then I want to know how long it takes to get from 30 metres to 60 metres. So if I find 60 metres, I go across and I read all the way down, it was 80 seconds. So to find how long it took to rise from 30 to 60 metres, I need to know the difference between 80 and 25. Remember, to find the difference, you need to do a takeaway. So I do 80, take away 25. Some of you can probably do that in your head. If you can't, remember you can always do a little column subtraction. Okay, 0 take away 5, can't do it, so I need to exchange. 10 take away 5 is 5, 7 take away 2 is 5. So my answer here then is 55 seconds. Okay, it's not 55 metres, because the question said how long it took. Okay, it took 55 seconds, because at 25 seconds it was already at 30 metres, and then at 80 seconds it was at 60 metres, and the difference between those then is 55 seconds. Okay, at this point then, Year 6, I would like you to pause the video and have a go at your work on maths.co.uk. Okay, once you've done that work today, I want you to come back to the video and watch the reasoning and plenary. Okay, Year 6, hopefully you've got on all right on maths.co.uk today, and you are back here to watch our reasoning question and have a go at that. So this question, we've got a new graph. It says Carol went on a 40-kilometre cycle ride. This is a line graph of how far she had gone at different times. Carol says, I travelled further in the first hour than in the second. Explain how the line graph shows this. Okay, so I would like you to pause the video now and have a go at writing your own reasoning answer. Once you've done that, if you come back and watch the video, and we will see how my answer compares to yours. Okay, Carol is talking about hours then. She says in the first hour compared to the second hour. So I need to know, first of all, that there's 60 minutes in an hour. So if I go to 60 minutes and I read across, then I can see how far she travelled in that first hour. So she travelled more than 20 kilometres, and we know that halfway between 20 and 30 is 25 kilometres. So she didn't go as far as 25. So I would say she travelled in that first hour approximately 22 kilometres. So I'm going to write hour 1, 22 kilometres. Okay, next I need to know how far she travelled in that second hour. So from 60 minutes to 120 minutes. So if I go to 120 and I read across, after 120 minutes she'd travelled 40 kilometres. But she'd already travelled 22 in hour 1. So I've got to do 40 take away 22, which is 18. So in hour 2, she travelled 18 kilometres. Okay, in terms of a reasoning answer then to explain my thinking, let's have a go at doing that then. So I've done the working out, and we've got to explain how the graph shows this. So first of all, I would say 1 hour equals 60 minutes. The graph shows that Carol travelled approximately, remember it's only an estimate when we're using a graph, approximately, and I've spelt that wrong, approximately 22 kilometres in the first hour. After 2 hours, and I can put in brackets 120 minutes, I'll just move this out of the way so you can see my answer. She had travelled. Sorry about that then, Year 6. My video was pausing me for some reason. She had travelled 40 kilometres. But, let's go comma, but only 18 of those were in hour 2. So, Carol is correct. She travelled further in hour 1. Than in hour 2. Okay, so 1 hour equals 60 minutes. The graph shows that Carol travelled approximately 22 kilometres in the first hour. After 2 hours, that's 120 minutes, she had travelled 40 kilometres, but only 18 of those were in hour 2. So Carol is correct. She travelled further in hour 1 than in hour 2. Okay. Final thing we're going to have a look at today then for our plenary. Tomorrow's learning we are going to be looking at bar charts and pictograms. Today we've looked at line graphs. So all of these are different ways of presenting data or presenting information. A question for you to consider then. How do we distinguish between a bar chart and a pictogram? So try and think back to the work you might have done lower down the school. What's a bar chart? What's a pictogram? And what's the difference between them? Pause the video now and have a little think. Okay, the key difference between a bar chart and a pictogram is in the name, really. A bar chart is like the second picture here. We've got bars of different things to show us some information. Pictograms, we have different pictures. So in this one here, the pictures are just little circles, but they could be little people or cars or trees, depending on what the data is that it's showing. Now here, the question is talking about cakes, which is why they've chosen to use circles as a pictorial image of what a cake looks like. Okay, so that's what we're going to be moving on and looking at tomorrow, and I'll see you then for that lesson. Goodbye.